Every atom in your body should have been destroyed 13.8 billion years ago, and physics still can't explain why it wasn't. In the first second after the Big Bang, matter and antimatter were created in perfect balance. When they touched, they annihilated completely. Nothing should have survived. No stars, no planets, no you. The universe should be nothing but a sea of cooling radiation, empty forever. And yet you're watching this. Something broke the rules. Something gave matter a 1 in a billion advantage. What was it? Here's what we thought we knew. Matter and antimatter are perfect mirrors. An electron has a negative charge. A positron, its antimatter twin, has a positive charge. Same mass, same spin, opposite in every other way. When they meet, they destroy each other completely. Pure energy, no leftovers. The Big Bang should have created exactly equal amounts of both. They should have annihilated in pairs until nothing remained. Think of it like shuffling a deck with 52 red cards and 52 black cards. You pull one of each, discard both, repeat. At the end, your hands should be empty, but they're not. We looked at the universe and found a card still sitting on the table. One matter particle survived for every billion annihilations. That tiny imbalance, 1 in a billion, created every galaxy, every star, every planet. But here's where it gets strange. We've never found a law of physics that explains it. The mechanism we're looking for has a name: CP violation. C stands for charge conjugation, swapping matter for antimatter. P stands for parity, flipping the universe like a mirror image. For decades, physicists assumed the universe treated matter and antimatter identically. Run the same experiment with each, get the same result. But in 1964, two physicists found a crack. Cronin and Fitch discovered that certain particles called kaons decayed slightly differently than their antimatter counterparts. The universe had a preference. It was picking favorites. Here's the problem. That preference is absurdly small. It explains maybe 1% of the matter we actually see. Wait, but think about this. The math says we need a bias of 1 part in a billion. We've found a bias of 1 part in 100 billion. We're off by a factor of 1,000. Something else is happening. Some undiscovered process tipped the scales exactly enough to create everything. Which leads to the part that most people never hear about. The matter around you isn't just unlikely. It's a rounding error that became an entire universe. That 1 in a billion survivor particle had 13.8 billion years to do something extraordinary. It clumped into hydrogen clouds. Those clouds collapsed into stars. The stars fused heavier elements. Those elements scattered when the stars died. New stars formed with planets around them. On at least one planet, those elements arranged themselves into molecules that could copy themselves. You are made of atoms that shouldn't exist, arranged by processes that took billions of years, reading about your own improbability. Every structure you see at night, every galaxy, every cluster is built from that tiny asymmetry. If CP violation had been slightly smaller, the universe would be dark and empty. If it had been slightly larger, matter might have clumped too fast, forming only black holes. The universe balanced on a knife's edge, and we still don't know who placed the knife. So the real question is, does this change what we think is possible? Right now, physicists are hunting for the missing piece. At CERN, researchers trap antimatter atoms for months at a time, measuring whether they fall up or down in gravity. Any difference could reveal new physics. At Fermilab, muon experiments are detecting anomalies in particle behavior that don't match predictions. Japan's T2K experiment fires neutrinos through 295 kilometers of rock, watching for asymmetries in how they transform. These aren't abstract questions for future generations. The data is coming in now. Papers are being published this year. One physicist told me they check their email obsessively, because any morning could bring the result that rewrites textbooks. We might be months away from discovering a new fundamental force, or we might learn that the standard model is missing something enormous. Either way, the answer matters for a very personal reason. It explains why anything exists at all. 13.8 billion years ago, matter and antimatter collided in perfect destruction, except for one survivor in every billion pairs. That survivor became everything. Every star you see, every atom in your body, every thought you're having right now. The universe shouldn't exist, but it does. And somehow, against all mathematical odds, it made something that can ask why. Here's my question for the comments. Do you think the asymmetry was random chance, or does it suggest something deeper about reality's structure? Follow for more, we post every week.